So, looking at this problem, does it have a GCF?
Yeah.
It doesn't. Can never be bigger than your smallest number. My smallest number is 3. The only factors of 3 are 3 and 1, and none of these are divisible by 3. They are divisible by 1, but that wouldn't change anything. So no GCF between the numbers. Also not between the variables because they don't all have an X. So what you do now is you keep following the steps, set up your diamond. Table 4, or not table 4, table 6. What will be my A times C for this?
15.
What? 15. 15. Okay, I thought I heard A. A times C, 3 times 5 is 15. Table 7, what's going to be my B? 16. Class, what are two numbers that multiply to 15 but add to 16?
5.
15 and 1. Because we needed to add to 16. All right, now normally we'd be done, but we're not, because if I write it like this doesn't multiply to give me 3x squared. So that's where you continue with the steps that I had you write down earlier. You need to divide the factors by A. Table 8. So can I get it? What was my A in this? No, that's my B. 3. 3 is my A. So we divide our factors by our A. Class, what's 15 divided by 3? 3, 5, actually, you're right, 5. And over here, is 1/3 reduced as much as it could be? Or can I reduce it more?
No.
It's already reduced.
Yeah.
So you slide that remaining denominator in front of the x, and that parentheses becomes 3x plus 1. And then when I multiply this out, now I'm getting my original. Now I'm getting the 3x squared, and then eventually I'll get the 16x. It would be 1x plus 15x, so sounds familiar. And then the last term, 5 times 1 is 5. All right, questions? Do we need to see another? Make sense? I would definitely not try to do this in my head. I would get out a piece of scratch paper or like a whiteboard or something, and I would be showing the work. That's the only way you'll internalize it. You have to be able to follow the steps. I don't know if it's asking you to solve it all, but if it's asking you for the zeros, that's where you set each factor equal to 0 and you keep solving. So like one of my factors for this one would be -5. The other one would be -1/3. Okay, but that's if it wants the zeros, the solutions, the x-intercepts. This, what we did in the lesson, is just factored form. Questions? Okay, well then I'll give you time to work on your practice. It's in Schoology. It's 7.10. As you are finishing, then you can show me the 80% or higher. Okay, so number 4 on today's, any factoring situation, what do you always check for first, Gunnar? And do I have one? Boys, can you, or girls, can you keep it down, whoever? Is there a GCF between 9 and 25? Did you say yeah? Oh, okay, because there isn't one. Can't be bigger than your smallest number. And none of these numbers divide evenly into 25 except 1, which doesn't count anyway. So no GCF between the numbers, also not the variables. So that's when you count how many terms you have. And don't include the equals 0 as a term. So Gunnar, how many terms are over here? And the only way we know how to factor a 2-term expression is if it's a difference of squares. If it is, then the factored form will look something like this. So first check. Is it a difference? Is there a minus sign between them? And then are there perfect squares on each side of the minus sign?
Yes, so then we are gonna factor it by that. When I do that, what's the square root of 9x squared? No, what times what will give me 9? Like that is this that's itself. Mm. So these are the only factors of 9. The square root of it is 3. And what's the square root of the x squared? No. What times what will give me x squared? That it's itself. Good. So my first square root is 3x. 3x times 3x will give me 9x squared. My second square root, what's the square root of 25? Good. So my parentheses look like this so far, and according to this rule, one of them needs to have a plus and the other one a minus. Now, what this is asking for is the solutions, not just what the factored form is. So this we've done kind of by memorization. We did it with the flashcards. But the ordinary way you would solve for it is by setting each factor equal to 0 and solving for x. So like in the first one, I need to subtract 5 on each side. It becomes 3x equals -5. Opposite of multiplying by 3 is dividing by 3. So my first x has to be -5/3 because it did say it wants it in fraction form, not a decimal. So that's one of the answers. The other one I get from adding 5 to each side, doing 3x equals 5, opposite of multiplying by 3 is dividing by 3. And that one is a positive 5/3. So don't put any extra spaces. That's how you would write it, these two answers. However, we have done before where we just like memorize the pattern just from the factored form, but the hard part was getting to the factored form, at least I think. All right, questions on this one? Does anyone else have questions on any others? Don't be shy. Because out of all the methods, I would say this one tends to be harder for students to understand. So, and maybe your teacher teaches it a bit differently. I like to teach you in the way that I think is the easiest, but there's lots of methods out there. So, um, here's the steps. If you didn't get the steps from your teacher, let me know later and I'll freeze it on the screen. But you always look for and check for a GCF if necessary. Then you look at how many terms you have to determine how you factor. And if A is not one, you have some extra steps. So let's do an example from the notes, because not everyone was here today, but they're here now. Okay, so if you want to take out your notes, you can. I won't force you to, but I do need your eyes on the screen. So we're going to solve this using the steps I told you. Let's look at the first one. Is there a GCF between 15, 18, and 24? 2 is not divisible into 15. 3, is there one that's greater than that, or just that one that's the greatest? It's 6 divisible in all of them. Okay, so here's a tip. It can never be bigger than your smallest number. So here's all the factors of 15. And 15 is not divisible into each of them. So go just down the list of like greatest to lowest. 5 is not divisible into each of them. So yeah, 3 is divisible into each of them. So 3 is my GCF, which we practiced that yesterday too. I think Evan's class is just like one day behind, so this might be completely foreign to you with your Evan's class, but I think you'll get it.
Needs to be more advanced for tomorrow. Anyway, my GCF is 3. That will go on the outside of parentheses. Inside should be what I get from dividing term by the GCF. And by the way, I kind of skimmed over this, but we couldn't factor out any variables because they don't each have a y. So we're just factoring out 3. So in my parentheses, dividing each term by 3, I get 5y squared minus 6y minus 8. So is everyone with me so far? Do you know how to factor by GCF? Sometimes you don't have a GCF, and then you just skip that step and go to the next one. But if you do have a GCF, once you factor it out, look at what's in your parentheses and see if that's factorable still. It's a 3-term expression, so the way that we factor 3-term expressions is by the diamond method. And I've conditioned you to know that it's always A times C on the top. Even if A is 1, which has been for like the past week or so, it's still A times C always. But this time A is not 1. This time A is 5. What's 5 times negative 8? Negative 40. B will go on the bottom. What's my B value? And now we're looking for 2 numbers that multiply to negative 40 but add to negative 6. Think about it, don't say it yet. Think of 2 numbers that multiply to negative 40 and add to negative 6. What are they? Now, would it add to a negative 6? How can I adjust it? Make it a negative 10 and a positive 4. Right? Now, does it work for the whole thing? Okay. Now, ordinarily in the past, you would think that you're done at that step. But if I were to multiply this out, I'm not getting the 5y squared. I'm just getting y squared. Here's how you get that different coefficient. And it follows these steps too that I have written over here. Once you find the factors, you need to divide those factors by what A was. Table 4, what was A? No. Well, I guess you're looking over here. That's my original problem. When I have a GCF, that kind of changes it. Right now, we're just factoring the parentheses. So what's A in the parentheses? Okay, so we're gonna divide by 5. Because we already factored out the GCF. We don't do anything with the GCF anymore. We're factoring this. A is 5. Now you need to reduce the fractions. 4 over 5 can't be reduced anymore. What does 10 over 5 reduce to? 2. Right? 2 over 1. So you reduce the fractions and then you slide any remaining denominators in front of the variable. And then you rewrite it. So what ends up happening is my final answer, so here's my GCF, but my final factor form ends up being 5y plus 4 and 1y minus 2. So sometimes we call it slide, like we slid the A over, we multiplied it by C, and then divided it later on. And then you have to slide in the remaining denominators again. So it's like slide, divide, slide. That's what happens when they. Questions on that? All right, and now when I multiply it, I am getting the 5y squared. Let's do one more, because I feel like some people are lost. Let's look at the one right next to it. Is there a GCF between 32, 16, and 2? Good, my GCF is 2. They're all divisible by 2. Do I need to factor out any variables? No, because they don't each have a variable. So we're going to keep going. My GCF will be outside the parentheses, inside will be whatever I get from dividing by the GCF. 32 divided by 2 is 16. This works out to -8W plus 1. Right, so we divided by the GCF. Good there. Now look at the parentheses. We're going to try and factor this, and it's a 3-term expression, so we're going to use the diamond method. Table 7, what's going to be my A times C on this one? 16. So that's me sliding the A over, timesing it by C, 16 times 1. Table 8, what's going to be my B value? That's factoring and giving them. What is going to be my B value? Close. -8. That would change what numbers I picked that make it work, right? We're looking for 2 numbers that multiply to 16 and add to -8. Table 2, what 2 numbers do that? Well, if I multiply them, then I would get a -16, which this should be positive. If I add them, I get a -6, so it can't be those numbers. What else multiplies to 16? Table 5? Wait, yeah, right? No. Oh. Wait, hold on. So it multiplies to 16. How do I make it add to -8 though? If one of them is negative, then it equals 0 when I add them. And it would multiply to a negative. We're almost there. If it multiplies to a positive but adds to a negative, then they both have to be. Oh. Okay, there you go. Right? Now it works. Multiplies to a positive, adds to a negative. Okay. So far, this is what I have. W minus 4, W minus 4. But wait, this doesn't multiply to 16W squared. That's why we have these extra steps. We need to divide our factors by A. Table 3, what was our factors? Or what was our A? 16. Not 32 because we had a DCF, so we're just factoring them parentheses right now. So divide by your DCF, not your DCF, divide by your A, reduce the fractions, and also I showed my class how to reduce fractions in the calculator. You don't have to like struggle that hard with calculator. Almost all calculators do this except for maybe like your iPhone. So if 4/16 is what I need to reduce, I type it. It gives me the decimal. If I want the fraction, I hit the decimal to fraction button, which is this button on decimals. So the reduced version of 4/16 is 1/4. So do we know what she's there? And what I have right now, W minus 1/4. I really have this fine. We reduced the fractions. Now you need to slide any remaining denominators in front of the variable. And then I get my GCF still on the outside. For my parentheses, it becomes 4W minus 1 and 4W minus, which really you can condense that by writing 4W minus 1 in parentheses squared. But that's how you factor. But it's more complicated. So if your practice is asking for the factored form, these are the factored forms. If your practice is asking for solutions, then they're asking for the zeros, the values for the variable that make it true. Usually at this stage is when it's easy to see the zero. Like I can tell you the zeros will be 1/4. for both, there's only one solution there. For this one of my zeros would be 2, the other one would be -4/5. We've done that with flashcards before. So if it wants a factored form, this is a factored form. If it wants solutions, it wants what the variable has to be to make it true. Questions? Okay, well then, you have time to work on your practice. Then we'll do questions. So I'm gonna leave it on this screen in case anyone needs the steps.
Okay, so if you don't need help with number 3, I'm just gonna ask you to stay quiet while I help others. Oh, okay. I'll try to get to that when I can. All right, so number 3, any factoring situation, which we're also gonna have to apply the zero product property after we factor it. But any factoring situation, what do we always check for first? GCF. Do I have a GCF in this one? I do not, because between 7, 22, and 3, the greatest factor they have in common is just 1, which wouldn't change anything. So no GCF there. Okay, I gave you another attempt. Hopefully I feel you with the one that was less. Anyway, then you are seeing if there's a GCF between the variables, and there's not because they don't each have an X. So you move on to the next step, which is to check how many terms you have. How do we factor a trinomial? Good, and that's always going to be A times C on top, B on the bottom. So A times C, what's 7 times 3? And my B value is what? And we're looking for 2 numbers that multiply to 21, but add to -20. Those are the factors of 21. So which one could possibly give me a -22 when I add or subtract them? Good. -21 and -1. That multiplies to a positive and adds to a negative. Now, ordinarily, we'd be mostly done here, but if I were to multiply this out, I'm not getting the 7x squared. So that's where you have to remember to divide each term by your a value. So what was my a value? So divide it from each of them and reduce the fractions. What does 21 over 7 reduce to? So this first parentheses will be x minus 3. The second one, I can't reduce it any more than it already is. So any remaining denominators, you should always have at least one that you have to do this for. You have to slide it in front of the variable. And that's what creates the 7x squared now when I multiply it. Now this is just my factored form. If you are to apply the zero product property, you have to set it equal to 0. Each factor, set it equal to 0. And then solve for what x has to be to make it true. So this first one, what -3 gives me 0? So one of my answers that I type in will be 3. The other one takes 2 steps to isolate the x, but it's pretty easy. You'll just add 1 to each side. You get 7x equals 1. Opposite of multiplying by 7 is. So if you were just trying to graph it and look at the x-intercepts, and you're probably having a hard time figuring out the answers, this is the easiest way to get the answers, is to actually do the algebra so you could see what fraction it is. And then you can compare it to the decimals on the x-intercepts. Whatever decimal it says should match 1/7, but that's how you actually solve it. Questions on that one?
So really, at this stage, so let me kind of go back. At this stage, it becomes really easy to see the zeros. Because you just know it's going to be opposite of whatever this sign is. And then opposite of -3 is +3. But I would still recommend, like, you have to know these steps for your test anything. All right, other questions? Number 4. Thank you. Okay. So, factoring and then solving by zero product property. Do I have a GCF in this one? No, because it can't be bigger than your smallest number. So it can't be bigger than 9. 9 isn't divisible into both. The factors of 9. 3 is not divisible into both, so no GCF, and also they don't both have an X, so no GCF at all. So the only way we know how to factor a 2-term expression is by what? The difference of squares rule. So this is the rule. It has to be a difference of squares, so it has to be a subtraction sign in between. Does it have a subtraction sign in between? And are there perfect squares on each side of the subtraction sign? So then, since it is a difference of squares, I just need to find my square roots. And then when I write them, one of them will have a plus in between and the other a minus. So what's the square root of 9x squared? 3x. Right, square root of 9 is 3, square root of x squared is x. And what's the square root of 25? So 5 here and 5 there. But again, one of them could have a plus, one of them could have a minus. Now this is the factored form. If I want to figure out what x has to be to make it true, I need to set each factor equal to 0 and solve for x separately. So in this first one, I would be subtracting 5 on each side. Then opposite of multiplying by 3 is dividing by 3. And it wants fractions, not decimals. So one of my answers will be -5/3. The other one, add 5 to each side, because that's the opposite of subtracting 5. Opposite of multiplying by 3 is dividing by 3. And my other one is, and it's hard to fit in right here, don't put any extra spaces in your answer. It's 5/3 and -5/3 for the 0. Which we've done that before with flashcards. You just like found a pattern. But that's how you actually solve it. Questions on others? If you haven't grabbed your phone yet, you can go grab it now.